This lesson is about calculating masses. There are three things you need to be able to do. The first of which is to calculate relative atomic mass, the second, relative formula mass, and the last, once you can do those two things, you can use them to calculate how much metal can be extracted during different reactions. The first thing you need to be able to do is to work out the relative atomic mass of different elements. This is just a way of saying how heavy each different atom is. Okay, you can work it out by looking at the periodic table. The relative atomic mass of each element, each atom of that element, is the number above it. So for example, lithium has a relative atomic mass of 6.9. Magnesium has a relative atomic mass of 24.3. We use the symbol Ar to represent relative atomic mass. So lithium has an Ar of 6.9. Magnesium has an Ar of 24.3. Make sure when you write it, you're making it clear that you're writing A with a subscript R and not the symbol for argon. This is not correct. So remember, relative atomic mass is just how heavy an atom is, and you can find it on the periodic table by looking at the number that's above the symbol for that element. Manganese has a relative atomic mass of 54.9. Potassium has a relative atomic mass of 39.1. Once you know how to work out the relative atomic mass of an atom, you can work out the relative formula mass. This is just how much one molecule of a different compound weighs. For example, we can look at a molecule of oxygen. Oxygen goes around in pairs. There are 2 atoms of oxygen in each oxygen molecule. We know from looking at the periodic table that the relative atomic mass of oxygen is 16. And we can see from the formula O2 that there are 2 atoms of oxygen. So we need to multiply 16 by 2 to get the relative formula mass of oxygen, which is 32. One molecule of oxygen weighs 32. Let's look at another example, sodium chloride. Sodium chloride has one atom of sodium and 1 atom of chlorine in it. Sodium has an atomic mass of 11, whereas chlorine has an atomic mass, an Ar, of 35.5. We add these together to get the relative formula mass, which we use the letters M subscript R to represent. In this case, for sodium chloride, that is 11 plus 35.5, which is 46.5. One molecule of sodium chloride weighs 46.5. Let's look at another example. Magnesium chloride has the formula MgCl2. This shows us that in each molecule of magnesium chloride, there's 1 magnesium atom and 2 chlorine atoms. To calculate the relative formula mass, first we need to know what the atomic masses of each of the atoms are. Magnesium has an atomic mass of 24.3. We got this from the periodic table. Chlorine has a relative atomic mass of 35.5. There's only 1 atom of magnesium in this molecule, so we only need 1 lot of 24.3. But there are 2 chlorine atoms, so we need to multiply 35.5 by 2. Then we need to add these 2 numbers together. Our 1 atom of magnesium weighs 24.3, and then we have 2 atoms of chlorine, each weighing 35.5. The relative formula mass, the Mr of magnesium chloride, is 95.3. 1 molecule of magnesium chloride weighs 95.3. The last example that we'll look at has got brackets in it, just to make sure that these don't confuse you. Magnesium hydroxide has the formula MgOH2. From this, we know that there are 1 atom of magnesium in this molecule, there are 2 oxygen atoms, and there are 2 hydrogen atoms. Then we can just work it out as we did before. Work out the atomic masses of each of those atoms and then multiply them together. Magnesium has a relative atomic mass of 24.3. Oxygen has a relative atomic mass of 16. And hydrogen has a relative atomic mass of 1. We need 2 oxygens, 2 hydrogens, but only 1 magnesium. Then you can add them all together to work out the relative formula mass. 24.3 plus 32 plus 2 is 58.3. The relative formula mass, Mr, of magnesium hydroxide is 58.3. The third thing you need to be able to do is to calculate the masses of different products of reactions if you're given the equation or the information about the reaction itself. Let's look at an example. How much copper can be extracted from 800 grams of copper oxide? I.e., if you dug up 800 grams of copper oxide outside of the ground, how much copper could you then get from it? To do this, the first thing you need to work out is the relative atomic mass of copper and the relative formula mass of copper oxide. The relative atomic mass of copper is 63.5. The relative formula mass of copper oxide is 79.5. This is step 1. Step 2 is to calculate the proportion of copper in copper oxide. You do this by taking the atomic mass of copper times by the number of atoms of copper there are in copper oxide. We know that the formula for copper oxide is CuO, so there's only 1 atom of copper in each molecule of copper oxide. So we times the atomic mass of copper by 1. Then you need to divide it by the relative formula mass of copper oxide, the Mr of CuO. We can use the atomic mass and formula mass that we worked out in step 1. So the proportion of copper in copper oxide is 63.5 times 1, because there's only 1 atom of copper in the molecule, divided by 79.5. That's the formula mass of that formula. This works out at 0.79. This tells us that for 1 gram of copper oxide, 0.79 grams of it is actually copper. The rest is oxygen. For every 1 gram of copper you get copper oxide, you take out of the ground, you can extract 0.79 grams of copper. Finally though, in step 3, you need to multiply your answer by the number of grams of the metal that you have. So we started off with 800 grams of copper oxide, not 1 gram. So we need to multiply our answer by 800. So 0.79 times 800 equals 639 grams. If we got 800 grams of copper oxide out of the ground, we would be able to extract 693 grams of copper from it. Let's look at another example. How much zinc can be extracted from 500 grams of zinc oxide? Remember, the first thing you need to do is calculate the relative atomic mass of zinc, which in this case is 65.4, and the relative formula mass of zinc oxide, which is 65.4 plus 16, as oxygen is 16. The relative formula mass of zinc oxide is 81.4. Then we need to calculate how much zinc there would be in 1 gram of zinc oxide. We do this by taking the atomic mass of zinc, 65.4, timesing it by the number of zincs in zinc oxide. Zinc oxide has a formula ZNO. There's only 1 zinc atom in each molecule, so we multiply it by 1. And then we divide all of that by the relative molecular mass of zinc oxide, which we've calculated as being 81.4. This works out at 0.8. Finally, we know that this is how much zinc we would get from 1 molecule of zinc oxide, but we started off with 500 grams of zinc oxide, so we need to multiply that by 500. This works out at 402 grams. If we had 500 grams of zinc oxide, we could extract 402 grams of zinc from it.